Okay, perfect. Let's get going then. Worked fine yesterday, but these things happen. So, yeah, today's session we're going to be talking about how we actually build automated model life cycles. So, how do we go through the process? What does a model life cycle look like? What kinds of things should it actually encompass for actually managing things? So, we're going to do a brief introduction right up front on a very standard guideline called SR11.7, which introduced some kind of high level concepts about what should actually be approached with model life cycles. And then we're going to give you a brief overview of what we utilize to basically automate these model life cycles, which is BPMN. So we're going to give you a brief introduction to that so you actually understand some of the notation and what we're going to do. And then we're going to actually show how you can basically implement SR11.7 within our product with using the BPMN notation and have all of that process largely automated and guided, so it'll actually help you through all the different steps that you actually need to do to be compliant with SR 11.7 on that. So the SR11.7 encompasses a lot. Now, I want to point out a lot of people, when they think about model life cycles, sometimes are only thinking of ML ops for basically the kind of train, retrain cycle. We're talking about a lot more than that here. To us, the model development is just one small part of the overall process. And it really actually begins with just the idea of just a use case definition. What problem are we trying to solve? What's the risk to the business, et cetera, and that kind of things. Then what kind of a model, and then you go on and develop one or more models to actually implement that use case, and we'll talk about that in more detail down the line. But then when we actually you have these hands off from first line to second line, where your first line may be going to develop the model, but then you're actually doing model validation, where we actually look at the model itself and do a review on it with a different team for making sure that it's not biased. The data that went into it looks of high quality, et cetera, et cetera. And then there's actually then it moves on to actually productionization, where we actually put it out into production to consume the model. And then obviously, and then this is shared with MLOps tools and things like that, is the idea of monitoring the model to see if the conditions have changed under which the model was originally developed, to then basically be able to readdress those at an appropriate time. And then all models pretty much have a shelf life. So the very end of the process is model retirement, of like, when do we have to do things such as either decommissioning the model, or do we have to schedule an annual review to recertify the model, or any of those kinds of things. So we'll be showing you how we can actually automate a large amount of this overall model life cycle. So as I said, this is a very complete. The idea of a model life cycle, now don't worry, we're going to later on dive down into these diagrams, is they are very large and they run over a long period of time. Typically, so there's the use case is development, but then it's getting out to production. There may be staging environments where it sits out for a period of time. It may be actually deployed out there. But the idea is we want to, at any point in time, be able to not only automate this process, but also provide traceability into where you are in this process, and then further actually um, you know, capture that information to be able to prove that you did go through all these steps. So if there's ever any question about the model and did you do your due diligence, you'll have that information at your fingertips to be able to prove to them that in fact this is what happens. So it's not focused on experimentation portion. That's what you typically see a lot of things being sold as a model lifecycle is. In reality, that the rapid kind of make, break, try, experimentate, tune, etc. That's what we refer to as the experimentation phase, and that is largely can be viewed as an open ground that however the data scientist wants to actually approach it, and the best of breed tools that make sense for the kind of model they're developing, they should absolutely be able to utilize those as part of the process. The auditors won't care so much about all those ones you end up discarding, because as we know, you try it a ton of times and you're going to pick a couple that are likely going to be your contenders for moving forward, for your actual implementation of that use case. So you won't see a lot about data science tools, or in particular any kind of like the hyperparameter tuning tools and all those kinds of things within these model life cycles. Instead, you're going to see things about like, was the submission complete? In other words, did they actually give us the original either training or baseline data, or some other kind of information about the model itself? So we have it. Did they give us the required documentation, and was the quality assurance done, and then being able to do data monitoring and stuff down the line? But also part of the model life cycles and what they actually need to do when you take in these considerations is you also need to make sure that they integrate with your existing IT investments. So you'll see things like, people already have quality code quality scans and stuff within their IT departments, usually fired by things like Jenkins and stuff. When you're going to want to interact with ticketing systems, and you're going to need to tie that all back to the model itself as well on that. And we're going to show you how that can actually be done on that kind of thing. So, keep in mind that overall, it's a very long process, a lot of steps, a lot of interactions, and you need your model lifecycle service that's providing this to actually be able to handle these kinds of integrations and long running processes. And that is why our particular product specifically decided to utilize big business process model notation, or BPMN, industry standard. It's been out there for a long time on that kind of things. And it's a great way of describing these long running processes. And it was designed to do this from the step. So within our product, that's how we actually let you basically draw out the model life cycle that will then, our system will become the conductor of the orchestra and move it through all of these different systems and capture all the metadata about those different systems. So whatever solution you're going with, it really needs to be kept in line with that, because a lot of people see this notation and they think of things like airflow, but airflow wasn't really meant to do these kinds of long running processes where you actually pull together information from different systems and have to wait for things to complete and those kinds of things. It's more of a quicker, more near real time kind of a solution here, whereas BPMN is excellent for describing that. So as we talk about how to actually implement these and what the individual steps should go into your model lifecycle, we're going to be basically looking at these BPMN diagrams here that actually do that. So I want to introduce you to some of the notations that we use behind that, so that you can follow along with the details of what we actually believe should be in a minimal model lifecycle implementation on that. So overall, we're going to be talking about processes a lot. So the BPMN process definition, is basically what will look like this. It's one kind of complete process from end to end, and you can have multiple different processes. And then within the process, you'll actually have, one starts in flight, so to speak, it becomes a process instance. So the process is the definition, and the process instance is the actual and execution of that process. So you'll actually have multiple instances, and those instances are what's going to get associated with the model, and we'll be able to trace the paths and choices it took as it went down and when these things occurred, and et cetera. And that'll make more sense as we look at the details of how these actually work. Then within these process instances, we'll be talking about process variables, because that's what actually carries the state between each of the individual activities that we're actually doing that, and allows us then to actually then make choices on the information contained within those process variables. So some of the symbols, just again to introduce this to people who may not be familiar with that, there's the concept of a start event. This is where the process starts. So when a process instance will be created, there's a couple different kinds. There's signals, which is basically externally generated by another process, or when using our product, we actually have signals that occur when different things occur with a model. So like if a model was modified or a new version of a model is submitted or those kinds of things, those can start one of these process instances to basically start the model lifecycle. Likewise, also timers can be used to actually do similar to a cron job where you can specify runs that, or a simple regular reoccurring duration like every 5 minutes or those kinds of things. So you can start processes that may be looking across multiple models as to what to do. So for instance, we'll be showing you later where we do an expiration check where we're looking for models that might need to be recertified on that kind of thing. So you want those to occur on a regular basis. And at the other end of the spectrum, literally, is the end events. Those actually terminate the process. So you can actually just do a simple termination, is what you'll see the most things. That means the process has been complete and will be marked as closed. And we will save that information. So again, we can refer back to where it was actually what actually occurred on that individual model. It could also start another process by actually ending and signaling another entity to actually get going as well. Or it can actually end in an error state where it requires attention and somebody needs to come and look at it because it just could not be completed successfully. And then we want to draw that to somebody's attention. So for instance, like if the job couldn't run or there was some kind of non things. There's also the idea of incidents, which they don't have a symbol for, but you can see when we actually use our product where it's a recoverable error and somebody could do something about it, like I couldn't talk to Jira or I couldn't talk to Jenkins or those kinds of things. So that will allow the process then to continue. So it's not actually really an end event, but it kind of will pause the process until somebody comes along and resolves the situation. And there's also the idea of boundary events. You'll see these on the edge of activities. They are basically, think of it like an exception in programming languages where, they can basically interrupt the running activity. So it could be a timeout. It could be we're talking to a service and there was a failure. There's a failure in running a monitor, like the data was bad that they gave us or something like that, or any of those other kinds of things, or something even like an escalation process where you could say, hey, yeah, after 3 days, nobody's taking a look at this. Send it on to the next person, et cetera, on that. So you'll see all of these utilized within our model lifecycle. We're actually going to define today for implementing that SR11.7a. 11.7, excuse me. And then what you're going to see the most of is activities. Activities are kind of the workhorses of the BPM world, as I put there that way. There's several different kinds, like user activities, or where you'd actually somebody needs to go do something. So it's a human doing it on that kind of things. There's business rule activities where we can evaluate conditions with DMN, a decision table. There's also scripting activities. A lot of people use these to reach out to disparate systems and things like that, where you can do different scripting languages. Most common you see in these environments is Groovy because it is a JVM-based solution, but it does actually technically support some other scripts as well and that kind of things. And then we could actually do things like sending an email or something like that is another kind of things. We don't really use these ones for the models, but they also have the idea of manual activities that have to occur outside of the actual automation orchestration service, but they will actually uh, again, somebody would have to come to the system and actually kind of kick it to go, and that's not something we particularly do. So you won't see that one as common, but I put it here just for completeness on that. Now, service activities are what you're going to see the most, and what we've done is create a whole bunch of model-specific services within our solution. So they're actually Java classes that get implemented within that, but then you interact with them through this BPMN notation, so you don't have to do any programming. You're just using a drag and drop style tool where you can interact with our services and our systems. So you can have all different kinds of things like launching a monitoring job to detect data drift. You could update a model with some additional metadata. You could read the latest versions of the model. You could get test results and look at those. And then you can grab all that information into those process variables and actually kind of, as you'll see in the next page, make some decisions based on that. And you will see that there's also the idea of external activities. These are long running processes that exist outside the BPM engine, like a JIRA work ticket. We're going to be looking at in specific, where we actually can go and kind of go in and like wait for the ticket to close out or have states or those kinds of things on that. And then you can actually organize all of these activities and choices and things like that into sub processes that you can then standardize across your organization and share, so you have a consistent way to actually build these items on that. Then finally, the other element I want to explain before we dive into the actual flow itself is the idea of the gateways, because these are important. In where it's really different than things like airflow and things like that on there is they actually allow you to basically control flow based on data from within the disparate systems. So, like yeah, we wait for a JIRA ticket to close and then say, well, did it close with done or did it close with rejected? And then take different paths based on those kinds of things. Those are the exclusive gateways where basically you can kind of make decisions and send route the model lifecycle down a different path based on some of the information actually contained within the model. There's also parallel gateways where you can branch out and do multiple tasks, and inclusive excuse me, inclusive gateways where it's basically like a fork and a join. So you can have the inclusive where you wait for all of the paths to complete before proceeding on, so you can parallelize efforts on that. The As you'll see our gateway uses, there's actually specific flows where you can actually specify a script or a specific expression to evaluate a variable, and based on the results, choose that flow. And then there you can also specify a default flow if there's no other matching conditions. So you'll see that within these definitions as well. So the model op center delegates are quite high level and really useful for building out these kinds of flows that really actually do business. So rather than being low level, you're trying to pull together and like do all this stuff yourself by hand or program it or script it all out with Python or these kinds of things. Instead, you can just drag and drop these higher level entities, pass them in different parameters and information stored within our model catalog to do stuff like run a test on an engine or deploy a model out to an existing deployment for live scoring, or do things like create a JIRA model review notification and then actually associate that back to the model so we can see the ticket and the status, et cetera, that's there, or get a specific result of a test and add it back in there. So you'll see all kinds of different high level processes that really make it easy to kind of do these different uh, higher level model reviews. Like I said, things like the standardized tests and that, as well as integrations with your existing IT resources like CI/CD processes through Jenkins or Jira and ServiceNow tickets, or existing RESTful/SOAP services you have within your organization. You really need to pull that all together to create a successful model lifecycle that's going to be usable. And in reality, that requires these higher level items and stringing them together and doing that. Because what we really want to do is go through and take this long list of items that you see here and automate absolutely as much as possible on it, and try to not have um, individual people having to manually cross-check things, et cetera, which we'll get into in a second and do that. So what we're gonna do is go step by step through each of these and look at how you can automate a lot of the steps within this overall thing. Obviously, at some point, like when you're doing a model review, a human is going to have to look at. But even then, we can make sure that happens in a timely manner, and make sure that you have quality submissions, et cetera, with that. So what we're actually going to do is, and don't worry, we're going to zoom in on these individual ones, but just to give you an idea, we have 3 different processes that we've actually implemented to automate this SR11.7, where we're going to look at the initial submission of the model all the way through productionization and deploying it out there. And that's this larger process here. And then we're actually going to look at monitoring of the models, and more important than just running the monitors, but actually looking at like, hey, well, if something goes wrong, what should we be doing if something goes wrong? What kinds of reports do we generate, and how can we automate those reports, et cetera, and that kind of things, as well as that last box where we talked about where models need to be either expired or recertified after a certain period of time on that. So we're gonna jump through each of these and kind of break it down as to how we actually do this within our system, and what kind of steps are actually done. So as we mentioned, ideally, when you're actually starting out the process of a complete model life cycle, you should start out with a use case and a risk determination. So what that means is define, yeah, what's the problem we're trying to solve. As soon as you do that, typically what you actually want to do is create a use case document that describes um, the overall process of like what success would look like for this model, and what it wants to predict, any potential data sources that may or may not be used, any kind of like PI kind of stuff, et cetera, on that protected data and things like that. But then what you want to do is actually then somebody else needs to review that use case document and actually determine the risk to the business of the model. So, is this like an internal thing that's being used and doesn't really matter that much or that kind of things? Or is it making a decision that if it were biased could come back and hurt the business or cost the business large amounts of money or that kind of things? So, how we do that is you want to be, again, have this automated so that as soon as we get a use case document, we actually create a ticket in Jira or ServiceNow or something like that, attach the use case document to that, attached have a use case model within our system is how we approach it. So there's a use case model, and then there's model implementations that are children of that use case, which we'll talk about that in a minute. But then you attach that to the Jira ticket, have somebody go out and actually review it in Jira, and actually then from there close out that ticket. Meanwhile, this orchestration process, will be waiting for that ticket to be marked as closed and the risk assigned, and will let you see that that's what's going on. And as soon as it actually then gets that Jira ticket, it'll actually create a notification about the risk determination, associate that with the model, and and take the assessment. Once the assessment is complete, update that model with the assessment and the notification so that all of that information is starting to build store. Because what we really want to do is build up a story about the model as we go along of that, yeah, we did do our due diligence. If you don't take these steps, you don't have the proof that any of this occurred. And that really becomes problematic if you do hit things. Then, as I said, what you would actually do is, now that you've got risk determined and you have a use case document and you've got that process and flight and information available, then you can actually go off and say, hey, go develop the model. And this is where your model lifecycle should ideally stay as much out of the way as it can, to let data scientists be data scientists and determine the best ways. You may want to use SageMaker for part of it, Python, straight Python for another, or maybe you want to play around with SageMaker versus Spark, and you have a few different things on that. So again, model lifecycle implementation should stay out of the way at this point and actually allow you the freedom to develop the model the way you want. And then once you're actually done developing the model, you submit the model into the model catalog and basically associate it with that use case and then proceed on. So now it's been waiting here for the experimentation to occur. Many different models could have been developed, thrown out, and you're going to have a one or more candidate models that you actually want to promote. Those models should ideally at this point, when you close out the ticket and provide that information, be complete models. So what do we mean by a complete model? So once it's developed, there's some information, if we're going to pass on to the model validation phase, that needs to be present to properly validate a model. If this information is not actually available, there's just no way you're going to have a successful thing. Now, in the past, I've seen in many corporations and different entities where they're bouncing back and forth between the first line and the second line constantly because you forgot the training data, or there's no definition of the schema, so I don't even know what the label column is, or et cetera, et cetera, et cetera. So this is where model life cycles can again automate some of the tedium of that back and forth by making sure there's a quality submission. So you'll see within our system, what we do is we actually provide the ability to verify certain assets are actually present on the submit on the model submission. On that, we can do that by looking at assets and the roles they're providing and the content of those assets to pull in there. So we can do things, for instance, like make sure there's an input and an output schema specified, so we do know the information about the data, which ones columns might be drift candidates, which columns might be might be a potential bias source or any of those kinds of things. So we can actually go through and use that BPMN notation to say, hey, are all of those items there? If they're not, don't even pass to the second line. Create a JIRA ticket. Again, I'll be the conductor of the orchestra here, back to the original developer immediately saying you're missing the training data, or you're missing the schema and the training data, or whatever resources that your second line demands are present to actually be able to verify and validate this model. So as you can see there, we actually go through and do that, and you can see that's how we make these decisions. We can look at these and say, yep, they have it. Likewise, there's often a large number of standardized tests that are actually run in an organization on based on whether it's a logistic regression or a categorical model, or what kind of a model it's being done. You'll want to run standardized tests, and we provide a whole bunch of those out of the box, but you'll also be able to automate your own. So as we build these out, you'll actually be able to set up those tests that should run based on the kind of model it is. So as remember, again, we can read information out of the model to look at it and understand the model type and what schemas are there and what can possibly be run on this. And then those standardized tests ideally run as in the ones we provide do run as a black box on the data itself. So it's actually looking at a sample and baseline data, or the original training data, et cetera, to analyze the data quality, the amount of data that's there, the actual things like accuracy, and all of those different things. Another thing, if you want to go to the kind of ultimate quality, I really like the Great Expectations tests. They're very tedious to set up. They're kind of like unit testing and programming, but we can automate those as well so that you can examine further data quality and then look at new data as it comes in and be able to rerun those on there. And there's a large, vast majority of these that can be run. And then ideally, again, trying to make the second line's life easier, there's often a model document review template. So our system will actually allow you to auto-populate information from those standardized tests into the document review, along with information about from the model, such as like who developed it, where it was done, what kind of model it is, et cetera, on that, so that the reviewer then just has to fill in the kind of the human part, where they go back and look at things such as um, uh, you know, the rationale behind what these test results means and stuff. So by automating as much of these items as you can in your model lifecycle, you really save a lot of time between the handoff from the first to the second line, but also a lot of time for the model reviewer to not have to run around, run these tests manually, although they may want to run some additional tests manually when they see the results, and that's certainly an option. But then also just kind of filling in all the boilerplate, because it gets very tedious and is not the fun part of the job in the second line. So it's nice to try to automate as much of that as we possibly can. And then once again, you send off and you actually create a ticket in Jira. So by the time the second line actually is called, they have a complete set of tests that's been run. They have a complete model. We know it's fully verified and that has all the necessary parts and pieces. And they have the start to their document review template filled out. So now they can actually go in and look and actually start doing the fun part of playing with the model, looking at additional situations, examining the data in further things, and having all that happen. And that all needs to occur, be documented, and that review, once it's actually completed, needs to be added back just to the model, just like the use case was, so that that's within your model inventory as well, because we want to build up and capture all of this information about the story. So you can see how much of this ends up getting automated by doing these model life cycles, and really helps kind of streamline that process on there. And then you actually, now that you've reviewed the document, now you actually want to do some things like SecOps on it. You want to make sure, does this model actually contain potential exploits or things like that? So, like for instance, we've seen several of our clients, they utilize Veracode fired by Jenkins. So again, we can automate the launch of a Jenkins job from our system to actually do the Veracode scan and capture the information about it. And again, if there's any vulnerabilities found, we can create JIRA tickets to have those resolved on that. So, we've not only proved out the rationale of the model, but we've also proved out the security soundness of the model, for lack of a better term, on that kind of things on that to make sure we do that. And then we can finally take like some of the sample data or something, just run a smoke test on it, make sure the darn thing runs. That's important to do as well to make sure that it's going to execute in the environments on that. And then you can finally do a kind of a final hotel room check review of everything to make sure that all of this does look right and does that and has that, and that's kind of your final sign off that the model's ready to actually go into a staging environment. Then again, some people will do a validation environment where we actually want to promote it in there and have it run on maybe some small sample of the data. It's a great idea to be able to do this just because it's another great way to catch bugs before it makes it out into production or anything like that with malformed or unexpected records or things like that. Because as we know, the data we get in the training is cleaned up, works, and is generally a higher quality than what may actually come over the wire if we're doing a live kind of scoping, or what may occur over time as data changes or has different values that perhaps we weren't expecting. So it's a great idea to run it in a validation environment. And this is where BPM helps out a lot again as well within our model lifecycle server. It can actually kind of pause itself for 1 week. And just wait on that, and it'll be sitting there, and then wake up and say, "Hey, yeah, now go create a review to make sure that it looks like the logs are good and it actually did before moving it on to actually being deployed within production." So this provides us that ability to kind of do that part, and BPM works great for that. Then finally, as I mentioned, we actually want to then, after that review, and we're going to move it out to actually get deployed within a production system, we want to set an expiration date. That varies by industry as to what should be there. Annual reviews are really common on that kind of things, and that doesn't mean you necessarily throw the model out, but it does mean you want to actually be able to take a look back at its performance and the monitoring results, which we'll explain in a minute, and be able to assure that that model is still relevant and functioning correctly. So you can see how we can move this through, and at any time, the original developer can go back and look and see where they are within this process, because we'll leave breadcrumbs behind to actually show them where they've actually been. But now that we actually have the model out into production and it's secure and it's making predictions. Now, this could be a batch prediction mode. It could be a live on REST, live on Kafka, Spark job, any of these kinds of things. It could even just be a deployment to Artifactory where people are downloading it from PyPy for their own uses or whatever. They all are considered deployed once people start actually using them for business purposes. So it's important to keep that in mind and to make sure that the services you utilize to manage this process can actually handle all of those different kinds of deployments and not just one kind of things, because you see a lot of solutions where it's just deploy to rest and it's things like that. We know that there's a lot more ways models are actually consumed within an organization on that. But what we do want to actually do is then we start our the model monitoring and continuous improvement phase. Now that means, yes, we do want to do things like automate things like stability analysis on the data, as you see here in this picture, or things like KS drift or different kinds of routines like that. We provide a whole bunch of those right out of the box that can be actually associated with a model. So you can have different models running different tests that make sense for that model, and also set different metrics or criteria for those items as makes sense for that particular model, because you have that, and we do that through decision tables is how we do it. But the idea is that we'll actually do batch runs periodically on a scheduled basis on the model as new data arrives on the new data, to make sure that it's the nature of the data from when it was developed to when it's now actually scoring, is not has not changed appreciably. But a lot of things will do that automated and maybe send out an alert. But what we really want to do, as I said, you want to more gather more data than that and that kind of thing. So you want to actually make sure that it passes, and if it actually does not pass and fails, we'd actually want to do things like a real common thing we see is actually generate an exception report immediately. So we actually take those results, put them into a Word document in an automated manner, associate them back to the model, and then again, make sure a JIRA gets assigned to somebody so that they can actually review it and determine whether or not this really is a failure that should result in the model being either retired, no longer used, or whatever. So we call that kind of actionable monitoring, and that you may need an additional 20 steps depending on what you do in your organization to handle this. This is a relatively simple flow showing how we can do that. But then if it actually passes, we still log that we ran these specific tests and this time and this day. So again, we can show our due diligence that we were doing the best we could all along to actually kind of keep tabs on these models and what they were doing there. So that's that continuous monitoring. And obviously the improvement portion of that is that once we have all this information in the model inventory and it's associated with the model, somebody can come back at any period in time and review the model, what's been going on, look for their own trends, because there's a lot of intuition that can go into this and looking at things. We can look at individual results and see if they fall outside of what expected norms are, but realistically, we see there's also a lot more kind of intuition that can go as a data scientist into going, that doesn't look right, and then take additional steps. And that's where those annual reviews can come in, where basically we can say, hey, we're getting near an expiration date on the model. Do we actually can create some warnings that actually say, hey, this is coming up, you're ready to review this, and the 15 days is short. We'd probably do something longer, but it's just an example here. But then if it's actually expired, we can go through and actually create JIRAs saying that, hey, this has actually expired. Now, in reality, what we often see is that this would actually just start an annual review process, or a periodic review process where somebody can go back and basically recertify the model in an abbreviated manner, because you already have all the documentation from when you originally developed and reviewed the model, and if it fundamentally hasn't changed, and all the predictions and concept drift and et cetera are still all looking good, you don't necessarily have to retire the model. But it's a good idea then to basically say, hey, I've re-looked at this. I've looked at the performance over the last year, and it's been fine. There's no anomalies that I see, and this all looks good, and then can recertify the model and put it out another year. Some models require that, no, we're going to retrain, or we're going to do this every X period of time. So the model's expired, we need to stop using it on that kind of things. And obviously, all of this can also be accelerated through that previous monitoring, where if we detect something has gone out of line, or there's a black swan event or something like that that occurs, we can force that the model should be retired at that time. So that's kind of the idea behind all of that. So that's kind of the expiration process and how we handle that. Why are we doing all this? It looks really complicated. There's a whole lot of information out there. We're going through a whole lot of steps, and we're capturing quite a bit through this process. Well, here's something. I mean, this is U.S. based, and we have people from all over. But Federal Trade Commission came out in April 2021, said, as we've noted, it's important to hold yourself accountable for your algorithm's performance. Our recommendations for transparency and independence can help you do just that. But keep in mind that if you don't hold yourself accountable, the FTC may do it for you. So what they're telling you right there is that's pretty serious. Is that you need to be able to prove you did all of these steps. You need to have that accountability in mind. Mistakes are going to happen. Black swan events are going to happen. Things are going to pop up. Like, I mean, when COVID happened, and people just stopped buying things the same way they did overnight, et cetera. Yeah, a ton of models got messed up. They started buying radically different stuff. That is going to happen. Nobody's going to come after you in those kinds of situations. But if somehow something drifts and you start making biased decisions, and you can't show you were doing your due diligence as the best way you possibly could to prevent that, then you could be fined. You could be, sued. You could be all kinds of things. And never mind, you don't want that as a company on your back that, you started making bad predictions because maybe it's not even just biased, you're losing tons of money, et cetera. To be able to go back at any point in time in your model inventory, show your overall model life cycle, how you actually went through it, the due diligence you put into it, the test results, the reviews, et cetera, like that, be able to do that with one click and bring it up when audited or even just asked about, you're going to be saving yourself a lot of headaches because they're going to see you did the work. If you don't have this and you just sit there and you try to rustle around some papers somewhere and try to find something, that could not turn out nearly as good. So as you go through these, and what I've introduced to you today about the extensiveness of SR 11.7, those are industry standard best practice. Of course, EU is coming out with their own items that are required for review, and we'll be doing some model life cycles based on those as well, on that kind of thing. So there's going to be a whole nother set of regs there. And so if you're using AI, you're going to have to prove all of these items, and if they audit you, you got to prove you did them. So this will help you do that, and that's why we do those model life cycles, to kind of keep ahead of where these things are. And the earlier you start doing them, the easier it's going to be. If you have thousands of models out there, it's going to take a while to prove back that you did it. So even if you only have a few models, it's way better to start there. I put it just like with unit testing in the software world, and integration tests and things like that. You need to have that same kind of rigor with your models as well, and perhaps even more so, because models do tend to change, degrade over time, whereas code kind of behaves the same way it behaves. So that was my goal today, is to kind of introduce you to all the steps that you need to do to actually ensure the quality of your models and that you're compliant within that process. So with that, I did want to leave 10, 15 minutes here at the end to open it up to questions. So if you have any questions, please feel free to go ahead and put them into the chat. Not seeing any questions, but I'll hang around for a couple more minutes if there's anybody else who does end up having a question and would like to see something. I'm happy to answer for you. So, on the access to the presentation, I believe that the Toronto Machine Learning Society is um, recording these. I'm not sure how they're making them available, to be honest. I apologize for that. But I know they did say that they were, it is, I can see it's actually being recorded. So hopefully you'd be able to reach out to them to get that. If you can't get this recording for some reason, please feel free to reach out through modelop.com directly, and just mention this. And I'm sure we can get you some PDF of the slides or something if you want that. But hopefully they'll make this recording available. Yeah, observability and model monitoring. I mean, model monitoring kind of can cover a whole lot of things where observability is kind of hand in hand with that. But model monitoring can be anything from any of the different kind of predictors or bias or explainability or even just simple volumetrics or any of those kinds of things. So model monitoring can extend that kind of concepts, including from our view, model monitoring can also be how do you put it? Custom code that you have that can perform any kind of analysis. Typically, we see these as black box kind of testing on the data, in that they don't particularly execute the model to make the predictions. I mean, there's nothing stopping you from doing that, but generally the idea is you want to treat it more in a black box manner where we're looking at original baseline data and usually some newer comparative data, or simply looking at predictions and looking for concept drift, or those kinds of things on that. And so model monitoring as a whole can be looking at that, but it could even be looking at things like performance, like is the model average prediction time creeping up or getting too long, it's falling out of an SLA, or et cetera as well. So it's a kind of a very, very open view of monitoring a model on that kind of thing. So I hope that makes sense. Yeah, model monitoring absolutely can look for auditing transparency or other kinds of items as well. Also looking for bias on predictions, on that kind of things, trying to get ahead of that, because as the input data changes over time, very much it could start it could, even though when you originally did it, it was not biased, you didn't think you put in anything that could be a bias indicator as an example, but maybe there's the hidden third factor you didn't really know about, and now your newer predictions are showing signs of that bias. You would want to then do something about it, or determine what it is, or things like that, to protect yourself against those kinds of situations. So again, that the monitoring can take into account anything, not only with the data associated with more recent predictions, but also even, as I said, like performance in an IT perspective as well, to make sure, because we see a lot of that where people use things like New Relic or things like that to actually look at overall average prediction time and make sure that a model isn't just slowing down, because maybe the data is more complex that's coming into it, is now just too slow. So we excuse me, we've seen that with one of our retail clients, where the prediction has to happen in like under 100 milliseconds, so they've lost the customer. So they want to keep close tabs on that. So it really can cover a large variety of different topics there. Yep, no problem. Glad to help. Any other questions out there? Excuse me. Yeah, I'll give it one more minute, and if I don't see any questions, we'll go ahead and break a little early. You never know how many questions there's going to be, so don't want to go over. Okay, well, I'm not seeing any more questions, so we're going to go ahead and wrap up. If anyone does think of something later, our basically modelop.com, you can go there. Feel free to reach out directly through that. We'll be happy to get you answers or provide things. We also have links to master classes and other things up on that site where you can actually view the product in action. Today, I more wanted to go through the theory behind it and the concepts, rather than diving into just a product demo. So if you want to see how this actually works in action in more of a product demo, I would suggest some of those master classes we actually have available online, where you can see how in action, how we actually run through these kinds of flows and how it works within our product. But hope you enjoyed the class today on there. And as I said, if you have any more questions, feel free to reach out directly through modelup.com, and we'll be glad to help you get an answer. So, okay. Thank you, everyone.